Hello everyone and welcome. This is looking at the ThatQuiz assignment. So once you click that link in the chat, you're going to find your name in the drop down menu and type in that password GCVS. So this is going to always be the password. Oh, we don't want to write. There we go. So you're typing in G, all lowercase, CVS, and then you're going to hit OK. And we're going to practice simplifying our radical expressions. So on the right side of the screen, you'll see I also have a chart of perfect squares. There we go, 1 to 30. So we can use that to help us work through this assignment. So the first one is looking for the square root of 49. So we look for that number 49. It is a perfect square, and so the square root of it is just going to be 7. Find it in the chart and match that up. Beautiful. For the next one, we have 2 times the square root of 81. So when there's a number in front of it, like we have here, it's being multiplied. So let's think if we can simplify our square root of 81. So we look in our chart, we find that number 81. So the square root of 81 is 9. So this is really 2 times 9. And 2 times 9, of course, gets us 18. So you're going to plug 18 into that box. And of course, remember, at any time you need to pause the video, please make sure to do so. Take care of yourself. You know what you need. Now for the next one, we see the square root of 300. And when I'm looking at my chart, I don't see the number 300, right? It's going to be somewhere between these two numbers, which means that 300 is not a perfect square. But let's see if we can simplify it. So we're going to look at our list. Is there a number that goes into 300 using multiplication? And I know the number 100 does. So we can rewrite this as the square root of 100, and 100 times what gets us 300? And of course that is 3. So this is the same thing as the square root of 100 times the square root of 3. Remember, we can split that up with multiplication just like we did in the pear deck. Well, the square root of 100 is 10, and then we're left with this square root 3. So our final answer here is 10 square roots of 3. We pulled out that perfect square. That's what we're practicing in this activity, is pulling out that perfect square. Beautiful. Let's look at the next one. Square root of 72. So looking on the right, I'm looking for that number 72. It would be somewhere between these two numbers, which means it's not a perfect square. That's okay. So we're going to think of a number that goes into 72. And if you're not sure, you can always go into the calculator and take 72 and divide it by 49. Oop, not minus. Divide it by 49. That gets a decimal, so it doesn't go in evenly. Let's try the next one above 49, which is 36. So 72 divided by 36. Oh, that one does go in evenly. Perfect. So we can rewrite this as the square root of 36 times that square root of 2, because 36 times 2 gets us 72. The square root of 36 we see in our chart right here is 6, and then we're left with root 2. That one cannot be simplified, so we just leave it as 6 times the square root of 2. And then hit OK when you're ready. This is the square root of 75. So looking at my list, I look for that number 75. I do not see it, which is okay. So I want to think of a number that goes into 75 out of our perfect squares. So again, if you're not sure how to do that, you can use your calculator and divide to find that number. I know that 25 goes into 75, right? So we can split this up as the square root of 25, and 25 times what gets us 75? And that is 3. So it's the square root of 25 times the square root of 3. The square root of 25, we can simplify, is just 5. So we're left with 5 times the square root of 3. And we're going to plug that in to our box. 5 times square root of 3. And then hit OK. Our next one is the square root of 90 times x squared. So when we have numbers and variables, again, if it helps your brain to split them up, because they're being multiplied under there, we can split this up as square root of 90 times square root of x squared. And we can kind of solve them separately. So let's look at the square root of 90 first. The square root of 90 is not a perfect square, right? It'd be in between 81 and 100. It's not on our list. So we want to think of a number that goes into 90. Well, 9 goes into 90, and that is the square root of 9. 9 times 10 gets us 90. So it's the square root of 9 times the square root of 10, and then we still have this square root of x squared. Now we can begin to simplify. The square root of 9 is just 3. Square root of 10 cannot be simplified anymore, so it just stays as is. And the square root of x squared, remember these are inverses. So when we take the square root of something squared, they're going to cancel out, and we're just left with that x. So we want to pull the x to the front. So we have a 3 and an x times the square root of 10. So on the outside, we took out a 3 and an x, and on the inside, we still have that root of 10. Beautiful. And then hit OK when you're ready. This next one is the square root of 400 y squared z. So again, my brain likes to split it up and think about it separately. If you don't need to do that, if you can like organize it in your head without doing that, that's fine. You do you. You know what's best for you. So we have the square root of 100. We also have this square root of y squared. And then we also have a square root of z. I put a little cross on my z to make sure it doesn't look like a 2. So first we have the square root of 400. Let's check our chart. We're looking for 400, and I do see it down here. 20 squared is 400. So the square root of 400 is 20. The square root of y squared, again, we have that perfect inverse. Boom, boom. They can cancel right out, and we're just left with a y. And we cannot do anything with the square root of z. That's just going to stay exactly how it is. It's perfect. So on the outside, we have a 20, and we have a y, and then it's multiplied by the square root of z. When you're all set, hit OK. Great practice, y'all. You're rocking it. This is the square root of 108a times b squared. So we can split this up just like we've done before as the square root of 108 times square root of a times square root of b squared. 108 is not a perfect square. I don't see it anywhere on our list. So we want to think about a number that goes into 108. So we can use our calculator, and when you do, you'll notice that 36 does go into it. So 108 divided by 36 gets us 3, which means we can split this up as the square root of 36 times the square root of 3, and then we still have this square root of a and a square root of b squared. Great. The square root of 36 is just 6. Root 3 will stay. We cannot simplify that any further. Root a will have to stay as well. And then the square root of b squared, those will cancel out, and we're just left with a b. So we want to pull that b to the front. So we have 6b out front, in front of that radical symbol. And inside the radical symbol, we have a 3, and we also have an a. That's taking care of these two terms. Beautiful. Let's look at the next one. So on the outside there, that was 6b, and then on the inside, we had a 3a. Our next one is the square root of 80 m squared n squared. So maybe you're starting to notice the pattern of what's happening, and what's going to happen here is this square root with the squared and square root with the squared for both the m and the n are going to cancel, right? If we wrote them separately, the square root of m squared is just m, the square root of n squared is just n. So there's definitely going to be an m and an n that we pull out. So we want to think about simplifying this square root of 80. Okay? 80 is not a perfect square. 81 is, it's close, but it's not 80. So we want to think about what goes into 80. And we could go into our calculator and we could type in 80 and divide it by 25. Ooh, that's close, but it doesn't go in exactly. Maybe 16. Perfect. It does go in. So 16 times 5 is 80, which means that this square root of 80 can be rewritten as the square root of 16 times the square root of 5. And the square root of 16 is 4. So we have 4 square roots of 5. That's how we simplified just that square root of 80. So there's going to be a 4 in the front. And then remember, we had the square root of m squared, and we also had the square root of n squared. And when that happened, when we simplified this, square root and square canceled out. So we were just left with an m, square root and square cancel out, so we're left with an n. So I'm going to clear the drawing. We have 4 mn, and on the inside we still had that square root of 5. Okay. Beautiful. I'm going to do another video for the second half so I don't run out of time here. So stay tuned and check out that second video, and we'll get started on this next problem. You rock.